So what is bond order? Bond order is number of bonds between two atoms. For example, in hydrogen molecule there is one bond between two hydrogen atoms. So bond order of hydrogen molecule is 1. In oxygen molecule O2, the number of bonds between two atoms of oxygen is 2. So bond order of O2 molecule is 2. Nitrogen molecule that has triple bond, that means bond order in N2 molecule is 3. So number of bonds between two atoms is also called as bond order. Greater the bond order, greater will be bond strength, lesser will be bond length. Alright. Now if you want to calculate bond order in resonating structures, as in bond number of bonds between two atoms keep changing. So we have a formula for that, which is total number of bonds between two atoms number divided by number of resonating structures. For example, I will explain it to you. In benzene, if we compare any bond, you pick up any bond, I will compare in both resonating. For example, I am taking up this one here and same this one here. How many bonds are there? 2, and here 1. So 2 plus 1, and number of resonating structure is 2. So 2 plus 1 by 2, that is 1.5. So bond order in benzene is 1.5. Similarly, in carbonate ion, let us pick up this bond, this bond, this bond, this bond. Now number of bonds 2 plus 1 divided by number of resonating structures is 3. So number of bonds in all resonating structures for a particular bond, 2 plus 1 divided by number of resonating structures, that is 3. So you get the value of bond order as 4 by 3, that is 1.33. Now we have bond parameters. What are these? Bond parameters are the properties of bonds, or we can say the properties of bonds in molecules. We call them as bond parameters. As in, if I say parameters of your physical appearance, we will have to tell your height, your weight and all these things. Similarly, for a molecule we will be talking about bond length, bond order, bond enthalpy. All these values we will be trying to understand how they vary, right. So over here we will be talking about bond length. So as number of bonds between two atoms increase, the bond length decrease, because attraction increases. Just imagine this, more the attraction between atoms, the closeness will be more, bond length will be less. Bond length is internuclear distance of two atoms involved in bond. The distance nucleus to nucleus is called bond length. So if they are attracted more, that means bond length is less. If they are attracted less, bond length is more. More attraction, less bond length, less attraction, more bond length, right. Just remember this. So a triple bond means more attraction, so bond length is less. Double bond, slightly attraction is lesser than triple but more than double, and single bond means attraction is least, so distance is more. So between a triple bond, double bond, single bond, the bond length order is single bond is longer than double and double is longer than triple. Alright. Next, if we want to know the values, you can easily understand the value is 1.2 angstrom, and here you will have 1.34 angstrom, and here you will have 1.54 angstrom. Alright. So these values you should remember, because we often get questions in organic chemistry on these. Alright. And here we have mentioned these values in picometers. So if you want to get values in picometers, multiply them with 100. Alright. And if we have different hybridizations, then also greater the percentage S character, smaller will be bond length, because attraction is more. So a bond which is between carbon sp hydrogen, carbon sp2 hydrogen and carbon sp3 hydrogen. So highest percentage S character is in sp. So bond length here is less, and as percentage S character decreases, bond length increases. So these are the values which we can figure out, or logically we can understand for comparing bond lengths. So with this we complete this